Hi and welcome to this Edexcel GCSE prediction for the higher tier Paper 1 May 2018 paper. Enjoy! Hi and welcome to this on maths prediction. So what we're going to do in this prediction is go through a predicted paper for the upcoming exam. Now what we mean by predicted paper is what we've done is gone back through the two exams that have already been sat for this, June and November last year, and we've picked out topics we think will come up again, and we've also picked out topics that didn't come up again. We've also looked through all the literature released by the exam board so that we can have a look at what they're hinting at will come up. And they've dropped some hints so far about certain aspects of this paper, which we've picked up on and put into this predicted paper. Now, this is, I think, the third year we've been doing predicted papers, and I say this every single year, and I hope that people are listening, which they clearly are, I hope. This predicted paper is not a be-all and end-all. Please don't use this as this is my one thing I'm going to do for the exam. I don't think anyone does, but I'm going to say this anyway. Use this as a revision strategy, just like you'd use a revision guide and anything else. It's a good way of just testing how your revision's going. And what a lot of people last year did was they did the test, had a go at it, see what they got, and then did the test a couple of weeks later to see if they've raised their grade. And just regularly doing the assessment will help you judge kind of what grade you're at. Now we construct these papers so that they're balanced by topic. So it's the example would say what percentage of each topic should be on the paper. We also balance them by assessment objective, basically difficulty of question. So they're balanced between AO1, AO2, AO3. If you know what that is, then brilliant. If not, don't worry about it. They're also balanced about grade. So the example would say roughly how much of each grade. They give it categories, but they're balanced along those. So it's an accurate paper in that regard. There are some questions that involve drawing and things like that we can't do perfectly, but hopefully we do it in a way that you definitely know how you'd use a compass or a protractor if you were asked to do that physically on paper. Now, those of you who've done predictions with us before would know that this entire paper is available on our website completely for free for you to try, and you can do it online. You can even register to save your scores, so you can have a go at the paper, come back a week later and remember what you got and see if you can beat your score. The website and this video will keep track of the grades as we go on, and on the website it shows you what grade you're at so far, and the difference between what your grade is and the maximum amount you could have got on the paper so far. So it's a really good tool to kind of judge what you need to do to get a grade 4, 5, 6, 7, 8, 9, whatever grade that you're looking for. The website also includes loads of other stuff. I'm not going to be able to go into all of it, but we've got topic busters are the main ones, which is every single topic at the new GCSE, and you can just go through and practice any topic you like. We've also got demon questions, which are the hardest exam paper questions. I was talking about assessment objectives earlier. These are AO3, which is the hardest ones. They're problem-solving questions generally, and they're the ones that students struggle with the most. So we've got demon questions that you can just practice the hardest ones. Now, obviously, there's lots and lots and lots more on the site, so please check the site out after you've watched this video. We also have a supporters club, which comes with a few extra perks. Obviously, everything on the site is for free, but one of the perks we're looking at including, and probably have by the time you watch this video, is a PDF download of some of the papers, including this paper. So if you want to consider supporting us, please check the link that's probably come above my head right now. So if you like this video, please click like. If you don't, obviously click unlike, and please consider subscribing. We're going to release the paper 2 and 3 papers just after paper 1 for paper 2 and just after paper 2 for paper 3. Those are more accurate predictions because obviously we can take off the topics that have already come up. I hope you enjoy this video. Thank you. Okay, so in this question we're given recipes for 12 biscuits, and that's going to be important. But we're also told that Fred wants to make 18 biscuits, complete the new list of ingredients, like the amounts of the ingredients. So I've got to somehow get from 12 to 18 by just timesing or timesing or dividing. So I can't really think of a way to get from 12 to 18 easily without a calculator directly. So what I'm going to do is I'm going to go to 6 first. I'm going to divide the 12 by 2, so halve it, and then I'm going to times the 6 by 3. And that will get me to 18. Now, some of you might think, well, why can't we just add 6? Proportion doesn't work with adding or subtracting. You've got to times or divide to keep everything into proportion. So what I'm going to do with each of these ingredients is I'm going to halve them to find out what the amounts for 6 biscuits are. And then I'm going to times them by 3 to find out the amounts for 18. So half the 84 would be 42. Half the 60 would be 30, half the 24 would be 12, half the 2 would be 1. And now, because we've got 12 biscuits here, and we've halved them to make 6, a different way of doing this is just adding them together. 12 plus 6 is 18. So instead of timesing the 42 by 3, I could just add it to the 84. So I could just do 84 plus 42, which would be 126. Again, 60 plus the 30, which is 90, 24 plus the 12, which is 36, and 2 plus the 1, which is 3. So the answers are 126, 90, 36, and 3. Okay, second part of the question says that we've got enough of every other ingredient, but only 1 kilogram of flour. Now, first thing to note here is that 1 kilogram is 1,000 grams. So that's really important to know for this. And we need 84 grams of, and I'm going to do my working up here, but normally in your exam, make sure you do it underneath the question. So we know that 84 grams gives us enough for 12 biscuits. So I want to work out how much 1 biscuit would be. So I'm going to divide both of those by 12 so that I can work out exactly how many biscuits I can make. So it's 84 and then divide it by 12, which you can do any method you want. The answer will be 7 grams. So 1 biscuit's going to be 7 grams. And now we've got 1,000 grams. So what we want to do now is we want to work out how many 7s there are in 1,000. So we need to do 1,000 divided by 7. And this isn't the only way of doing this. Now, to do 1,000 divided by 7, what you could do is just keep going through the 7 times table. You might start off with 7 times 100, which is 700, and keep going there. Or you might use the bus stop method. And there's loads of different ways of doing this question. So I'm going to use the bus stop method. 7s into 1 don't go, so that 1 carries on. 7s into 10 go once, and then we carry the 3. 7s into 30, well, 5 times 7 is 35, and 4 times 7 is 28, so it's going to be 4 with 2 carried on. 7s into 20, well, 7 times 3 is 21, 7 times 2 is 14, so it's going to be 2. Now, we could carry on and push on the 6 remaining, but actually it just shows us that we've got 142 whole biscuits and then some biscuits left over at the end. So we're only interested in how many biscuits he can actually make, which would be 142, but he might have like some flour left over, but it wouldn't make a biscuit. So the answer is 142. For these types of questions, always make sure that you show your working, show how you know something is something. So the way I would start this, and this is not the only correct answer, is I realise that these two are the same. So I know that 2y minus 50 equals 52. The reason I know that is that they are corresponding angles. Now, some of you might know that as F angles, but make sure you write the word corresponding because they won't accept any other word. So I can solve this by first of all adding 50 to both sides, So that's 2y equals 102, and then I'm going to halve both sides. So y equals 51. So I know y is 51, so I now know that this angle here is 51 degrees. Now I know that this is 52 degrees because if you look at this, I'll use a different colour, this angle here and this angle here are z angles or alternate angles, or you can say that this 52 degrees here is equal to this here, which is also 52, because they're vertically opposite angles. So I know that this one here, and I could call it a letter on the diagram, so I could say C. I don't think there's another C, so C equals 52, and show the examiner, right, that's because, well, let's go for alternate angles with the original value. Okay, so we've got three sides, or three angles in a triangle. I've got way too many colours going on here. So to work out x, so x equals, it's going to be 180 minus 51 plus 52. So work out what 51 plus 52 is, and then take away from 180. And the reason is angles in triangle. Okay, so I know that 51 plus 52 is going to be 103, and therefore that's going to be 77 degrees. So my answer is 77 degrees. Okay, so for this question, we're given a plan of a garden, and we're given a set of instructions of where the tree can be planted. So it says that we can't be any closer than 5 meters, so at least 5 meters away from point C. So that's from here. So let's have a look at that first. Now I'm going to find it very difficult to make this perfect because I can't draw circles or arcs on this. However, I'm going to try my best to show you roughly what it should look like when you do it on paper. So you need a compass for this, and with the compass you would measure out 5 centimeters, which I'm sure that's the scale of this. So you'd measure out whatever it says the scale would be. So for this one, I'm imagining 1 meter is 1 centimeter. And you would draw a kind of quarter circle with your point of your compass at C, and you draw like a quarter circle like that. And that's not too bad, although it looks it looks closer to B than it should be, but it's not too bad. Okay, so that's that first bit sorted. Now it says the tree must be closer to CD, which is this bit here. So it's got to be closer to this than AB, so than this. So what we need to do is ensure that it's closer to the red line than the green line. Now to do this, you need to do a perpendicular bisector of AD or BC. Either one would work. So you get your compass and put it at point A, and you measure out something that's more than 5 centimeters. It doesn't matter how much more. And you do an arc, like a bit of the circle this side and a bit of the circle this side. You do the same at D, and you do a bit of the circle this side and a bit of a circle this side, and then you join those up. So I'm going to join those up and just keep going like so. Now that will give you a perfect equidistant line from AB and CD. Mine's a little bit high, as you can see, but on your one it should look perfect. So it says shade the region the tree can be planted. So it's anywhere, and I might do a different colour for this so it just stands out a little bit. It's anywhere here. Now you always just double check this. So the blue shaded, and on your exam don't bother with a different colour, just use a pencil to shade it in. It says the tree must be at least 5 meters away from point C, which mine is, and the tree must be closer to CD than AB, which mine is. Okay, for Venn diagrams it's really important to understand the notation. This symbol here means union, it just means or. It means it can be in A, or it can be in B, or it can be in both. So it's any number inside either circle. So I could have 9, 5, 3, 7, 18, or 2. Let's go for 9, but the other 5 would be correct. This symbol here, I always view it as an AND. I always put a little line there to say A for AND. And it means it needs to be in A and B. It can't just be in A, it can't just be in B, it needs to be in both. And there's two numbers that fit that bill, 3 and 7. So I could write 3 or I could write 7. Now this little symbol here, okay, and it's an A with a dash. That dash there means not. So we're looking for numbers that aren't in A and are in B. Well, let's have a look at where not A is. Well, it's anywhere around here. Anywhere around here is not in A. And let's have a look at where B is. So B is anywhere here. So the numbers that overlap both of those are the 18 and the 2. So it's 18 and 2. So there are two numbers that fit that bill. So that will go at the top of our fraction. And there's 1, 2, 3, 4, 5, 6, 7, 8 in total. Now I can simplify that a little bit to make it a quarter. And so my answer to that will be 1/4, or a quarter. Right, whenever you're asked to estimate, basically what that means, it normally is round everything in the question to one significant figure and then work it out. Now there are a few exceptions to that. For instance, if you're asked root 82, the easiest thing to estimate that to is root 81, not root 80, because you know what root 81 is. Root 81 obviously is 9. But mostly it's one significant figure. So we're going to go through everything in the question and just round it to one significant figure. Now, 64, for 64, the line goes after the first digit for significant figures. That 6 will stay as a 6 because that 4 is less than 5. And that 4 will just turn to a 0. For 160, the line will go between the 1 and the 6. That one will round up to a 2 because the next number is 5 or more. And the other numbers will turn to 0. 22 at the bottom, line goes down there, that rounds to 20. 98, line goes down there, the 9 will go up to a 10, and the 8 will turn into a 0. So that question turns into 60 times 200 over 20 times 100. Now there's different ways of doing this. I mean, we can multiply them out. So 6 times 2 is 12 with 3 zeros. 2 times 1 is 2 with 3 zeros. And then we can just cross off the zeros. So 1, 2, 3. And then we're left with 12 divided by 2, which is going to be 6. And when I say cross off the zeros, what I'm doing is dividing top and bottom by 10, and then by 10 again, and then by 10 again. So the answer is 6. There are different ways of doing it. I could have cancelled down at this stage here and divided top and bottom by 20. So that would leave 10 there. And then divide top and bottom by 10. So that would leave 10 there. 60 divided by 10 is going to be 6. Loads of different ways of doing it. Okay, this is quite a lengthy question, and again, it's one of those questions, there's multiple ways of doing it, so if you've got a technique that works really well, stick with it. But with this question, and with any fraction questions, you need to make them top heavy first. So that's what I'm going to do with both of these fractions. So 6 1/3, and to make it top heavy, you times by the bottom, and then that answer you add to the top, and then you keep the bottom the same. So 6 times 3 is 18, add to the top is 19, but keep the bottom the same, so it's still over 3. So 4 1/2, we times by the bottom, which would be 8, and then add it to the top, which would be 9. So that equals 9/2. So we're going to do 19/3 times 9/2. So I've written the same thing, 6 1/3 times 4 1/2, but instead of 6 1/3, I've written 19/3. Instead of 4 1/2, I've written 9/2. Okay, so one thing you can do at this step, which will help us write it in its simplest form, is you can divide anything at the top and anything at the bottom by a number to simplify it. So the 9 at the top and the 3 at the bottom, I can divide them both by 3. So that will leave 3 at the top there, and it will leave 1 at the bottom there. Now, this is really important because if I times these across, I would get a really big number. Now, I'm still going to get a big number, but it's a lot smaller and a lot easier to spot how to simplify at this stage. Okay, and some people call this the bow tie method because if I draw a nice bow tie over it, it can be any number at the top and any number at the bottom. So it can be down here, or diagonally across, hence the bow tie method. So now instead of doing 19 times 9, I'm doing 19 times 3. And you can do any method you want. I mean, some of you would do 20 times 3 and take away 3, but let's do a little grid. 19 times 3, 30. 3 times 9 is 27. So 30 plus 27 is going to be 57. And now we're doing 1 times 2, which is 2. Now, it says that it wants it as a mixed number, so we need to do that now. So 57 over 2, we need to make that mixed number. So we've got to work out how many 2's there are in 57. Well, I know that 56 divided by 2 is going to be 25 plus 3 is 28. So there's 28 whole ones and 1 remainder. So what you do is you work out how many 2's there are in 57, which is 28, and then any leftover, any remainders at the top, just create the fraction. So the answer is 28.5. Okay, so for this question, it's really common to take the wrong approach with this. For instance, the biggest wrong answer for this is to try and get from 6 to 4, so we can divide it by 3 and then double it. So we're going to divide the days by 3, which is 4, and then double that. So the most common wrong answer is 8 days. And I understand why people put that answer down, but think about it logically. 6 people take 12 days. 4 people, which is less, so you imagine there's a task and you've got 6 people and then you've got 4 people, okay? You'd expect it to take longer. So if it took 12 days before, it wouldn't suddenly take 8 days. Otherwise, why would people employ more people? Why would a foreman employ more builders if less is better? So we know that that's the wrong answer. How do we work out the correct answer? Well, there's a really simple way of thinking about this, and it's to think about this thing I'm just making up now called people days. So every job has an amount of people days. Okay, and to work out the amount of people days for this, you get the amount of people, which is 6, and you times it by the amount of days it takes, which is 12. So 6 times 12 is 72. So it's going to take 72 people days. So for instance, if we had one person, which we could have, it will take that one person 72 days. If we had 2 people, it would take them half of the 72. So it says we've got 4 people. So what we do is you get the amount of people days, which is 72, but we don't have one person anymore, we've got 4 people, so we're going to divide it by 4. Now an easy way to divide something by 4 is to halve it, then halve it again. So 72 divided by 2 is 36, then halve it again is 18. So the answer is 18 days. Now let's have a look and see if that's realistic. Well, it took 6 people 12 days, so 4 people, which is less, will take longer. So instead of 12 days, 18 days. Now there is an assumption we've made, and that's that all the people work or paint at the same rate. Now it could be that the 6 people we originally had were kind of lazy, not very good at painting, had other distractions, and the 4 people we had are amazing people at painting, and actually maybe they did take less time. Or it could be that it rained when the 6 people tried to do it, and it didn't rain when the 4 people tried to do it. Don't get too creative with your explanations. they're looking for just some understanding that this is what we call in maths a model for working stuff out, and it doesn't always work. Because whenever you're working with people, people are different. We're all different. We've each got our individual differences. So anything that says that the people might not work at the same rate, absolutely fine, we'll get you the mark. So to answer this question, we need to be really familiar with the formula y equals mx plus c. Now y and x will constantly change, but m is what we call the gradient, and c, or plus c, is what we call the y-intercept. Okay, so we need to understand how to use that formula for this question. Now it already tells us that the gradient of the line is 3, so we can fill that in. So it's y equals 3x plus c. Nice and easy. The only thing we don't have is the y-intercept. Now, the way of getting the y-intercept is substituting in the values we know. We know when x is 3, y is 17. So what I'm going to do is just put in the values. Put in the values of 3 for x and 17 for y. So it's going to be 17 equals 3 times 3 plus c. And I'm going to put my lines in so that I can solve it. So that's 17 equals 9 plus c, and we're going to take away 9 from both sides, so it's going to be 8 equals c, or just c equals 8. So looking back at this formula we had earlier, we had m but we didn't have c. Well, we now have c, which is 8. So it's y equals 3x plus 8. And you can check that by putting in the values of 3 as x, and see whether you get 17. 3 times 3 is 9, 9 plus 8 is 17. Okay, so we have a set of simultaneous equations, and I'm just going to start off by just writing them out to give myself a bit more room, because it's a little bit too small otherwise. So I'm just copying out the question. Now, there's a list of things we need to do for these, and there are different methods. I'm just going to go through the main one. The first thing is I need to get either the x's or the y's the same coefficient, so the number before them needs to be the same, ignoring signs. Now looking at this, and I'm going to label these a and b. Looking at this, if I double a, then the x's would become the same because they both have a coefficient of 4. So what I'm going to do now is I'm just going to write 2a. So I'm going to double everything in a. So double the 2x to make 4x, to make the x's the same. Double the 5 before the y, so that's 10y now. And double the 24 to make 48. Now, next, I need to probably, and it's normally the case, that if I write down b again, it just makes things easier. So I'm just going to literally copy down b underneath. Okay, so next I'm going to remind myself that I'm working downwards now. So I just put little circles around these to remind me I'm going downwards. And I need to look at the sign before the letter that I've made the same coefficient. So I'm looking at the x's and I'm looking at the signs before them. If the signs are the same, we are going to subtract. If the signs are different, we're going to add, and it's that simple. Okay, now the signs are the same because they're both positive, so we are going to be subtracting. So a minus there, a minus there, and a minus there. Okay, let's start. 4x take away 4x is nothing, which is good because it needs to be nothing. 10y minus 3y. Now 2 minuses make a plus, so that's 10y plus 3y, which would be 13y. And we've got 48 plus, because the 2 minuses make a plus 4, which is going to be 52. I'm going to put my lines in. Okay, next I need to do 52 divided by 13. And we're going to do both of these divided by 13. So we've got y equals, I think it's 4, so 4 times 13 is 52. So yeah, y equals 4. Then I'm going to pick one of the equations from the question and I'm going to substitute the 4 in. I'm just going to pick the top one. So 2x plus 5 times 4, because we know that y is 4, equals 24. And again, put my lines in. So it's 2x plus 20 equals 24. Take away 20 from both sides. 2x equals 4. Divide both sides by 2. Extend my lines a little bit. And x equals 2. Now if you've got time in the exam, you can check that that's right by using the second equation. So 4 times 2 is 8. 3 times 4 is 12, and 8 take away 12 is minus 4, so we know it's correct. So x is 2 and y is 4. Okay, this question looks quite confusing because it says the weight of the sack is 19 kilograms, but then it asks you for the smallest and largest possible weight that it could be. So it seems quite confusing at first, until we realise that it is rounded to the nearest kilogram. So the first diagram I draw out is just a line, and I put 19 in the middle. And I think to myself, right, what was the next one down that it could have been? If it wasn't 19, if it was less, what's the next one down it could have been? Well, the next one down would be 18. And then I think, well, what's the next one up it could be? Well, it could have been 20. It's not 18 or 20, it's 19. And then I think, well, what's the cutoff point between 18 and 19? So I draw a line down here, and the cutoff point would have been 18.5. So if it was 18.4, it would have been rounded to 18, but 18.5 or more, it's rounded to 19. And I do the same on the other side. So I draw a line between here and here, and this time I think, right, what's the cutoff point for this one? Well, that's 19.5. Now, this second one's a little bit more complicated, because you might think, oh, actually 19.5 would round to 20. So it's 19.49 recurring. Yes, you would actually be true. Unfortunately, 19.49 recurring is actually the same as 19.5. So for our smallest possible weight, we put 18.5, and for the maximum possible weight, we can actually put 19.5, even though we know that would have rounded to 20. Now this works because it's a continuous scale. If you were doing an amount of counters, say if it was 19 counters, or I don't know, 190 counters to the nearest 10, then the lowest one would be 185, that would be fine. But the highest it could have been before it was rounded to the nearest 10 would be 194, because you can't get like a 0.1 of a counter. So just be wary of that if you're working in discrete calculations, so things that can't be 0.00001 or something, then you do like 4 at the end of it for the maximum. But if you're working with heights, weights, things like that, then 19.5 for this one is absolutely correct. Okay, so here we've got a box plot, and it's important to understand the parts of a box plot. There are always 5 parts. We've got the lowest value, which is the start of the box plot. We've got the lower quartile, which is the start of the box. We've got the median, which is, if I can line it up right, which is the line in the box. Then we've got the upper quartile, which is the end of the box. And then we've got the highest value, which is the end. So when it asks us for the median is halfway between 10 and 12, which will be 11. And it will ask us for the interquartile range. Interquartile range, IQR for short, is the upper quartile, take away the lower quartile. So the upper quartile here is 18, and we're going to take away the lower quartile, which is halfway between 2 and 4, which will be 3. So it's 18 take away 3, which is 15. Okay, now next it says that the table shows results of cats. I think the first one was dogs. And compare the two distributions. Okay, you must always compare the medians. So looking at my dogs, or looking at my answer to the dogs, it was 11, and the median here is 15. So you need to write a sentence saying that the median for cats, which was 15, is higher than dogs, which is 11. So always state the values. Now you can also say on average they're higher because the median is 15 for the cats and only 11 for the dogs. As long as you're comparing the medians and saying which one's higher, or maybe they're the same. Okay, the interquartile range for the cats is 23 and for the dogs is 15, and the next thing you need to compare is a range. Now you could pick the overall range, or it's probably easier just using the interquartile range, and I've just done that wrong because the interquartile range for the cats obviously would be 23 take away 10, which is 13. That's very different. Right, so for the cats it's 13, for the dogs it's 15. Now 13 and 15 are not that far away, so you might say they are more or less the same, or you might say that the interquartile range is higher for the dogs. As long as you back it up with the numbers and say something that makes sense, then that's absolutely fine. The way of starting this sentence, so I said on average is kind of the way to start when you the sentence when you're comparing medians. For this one, you just say the spread of data for dogs is slightly higher than with cats. And then you'd say, since IQR, interquartile range for dogs, is 15 and for cats is 13. So whenever you're comparing the medians, you really should start with on average and then say the medians and write a comparative comment. And always start the sentence when you're comparing a range or an interquartile range with the spread of the data. And it just makes you makes the examiner realise that you know what you're talking about. Always include the numbers as well, and that's really important on some of the papers that you're referring to something. The first comparison is always the average, so the median, when you're comparing box plots or cumulative frequency graphs, and the second one is always the range, and that's really important to remember. Okay, so whenever we're asked to find an inequality or draw an inequality onto a graph, always draw the line but without the inequality in it. So instead of x is greater than or equal to 5, always draw the line x equals 5. If it can be equal to it, it's a solid line. If it can't be equal to it, it's a dashed line. Okay, so it's x equals 5, and I'm going to draw a solid line. So where does x equal 5? Well, x equals 5 here, and here, and here. And in fact, anywhere along that line, it's just a vertical line up, and that's the line x equals 5. And it's really important to remember which way around it is. Whenever you have x equals something, it's always a line from top to bottom. When you have y equals something, it's always a line from left to right. Okay, that's the line x equals 5, but it asks us to mark the region in the inequality with an R, so it's either going to be to the left or the right of this line. Well, it says that x can be anything that's greater than or equal to 5. So x could be 5, 6, 7, 8 on this graph, okay, because obviously it only goes up to 8. So anywhere this side of the line is absolutely fine, so I'm going to mark my R there. And actually sometimes the exams ask you to shade it in, so I just shade in that right hand side of the graph. Sometimes you shade in what you don't want, and if I was shading in what I didn't want, obviously it would be on the left hand side of that graph. Okay, so there's a couple of formulas we need to remember with this. We need to know the trigonometric area formula, and that is the area is half a b sine c. A and b are the lengths either side of the angle, and c is the angle. And the other one we need to know is just normal triangle, half base times height. And it's a right angle triangle, so we've got the height and we've got the base there. Okay, so it says in the question that the areas are equal. So we're going to work out the area of A, we're going to work out the area of B, and then we're going to get them equal to each other. It's that simple. So to work out the area of A, we use our trigonometric area formula. So that's half AB, A is x and b is x, that's going to be x squared, sine the angle, which is 30. And the other formula for the other triangle is going to be half times 1, well anything times 1 is just itself, times the height. Now whenever you've got an expression, always put it in brackets. So I'll put this in brackets. Okay, cool, right. We're going to tidy this up a little bit before we start solving it. I'll need longer lines than that, so I'll just draw these down a little bit longer. Okay, you need to know that sine 30 is a half, okay, and that's a requirement for the exam. So you need to know that that is just going to be a half without a calculator. We've got loads of videos on exact values that you need to know, and I think there's 8 of them you need to know. I probably got that wrong. But anyway, so we're going to expand the bracket. So half x plus, and our half of 3 is going to be 1.5. Am I sure? Yeah, that's right. Okay, cool. Okay, next thing we're going to do is, looking at that, I'm just going to times everything by 2. I'm just going to times everything by 2. And you've got to times everything by 2, so don't just do it once, both sides. You've got to times everything by 2, and actually that's part of the same term. So anything that's separated by plus or a minus, you've got to times by 2. Okay, so here we have x squared times a half equals x plus 3. Cool, right, okay, so next we're going to I'm going to times everything by 2 again, actually. Should times everything by 4. Get rid of the half. So we've got 2x plus 6. Okay, now looking at the requirement in the question, it says it wants it in the form a plus minus root b. Now that hints at the fact that we are going to complete the square to solve this. It means that basically we can't work out the exact answer, but we can show it as a square root. You could also use the quadratic formula. I'm not going to do that. I'm going to do completing the square. To complete the square, you need the x terms on the same side. So actually, I'm just going to write down what I'm doing. Got ahead of myself. I'm going to take away 2x from both sides. I'm going to extend my line even more. And so we've got x squared minus 2x equals 6. Now to do this, what we need to do is we need to put a set of brackets down, and it's going to be x, and it's going to be half of the number before the x. So if you have a look here, it's a 2 there, so we're going to subtract 1 inside the bracket, and we're going to square it. Okay, there's loads of videos on completing the square, so if you don't know how to do that, just check out the video. Just type in on maths completing the square. We've also got an erroneous 1 that generates, which we don't want, so we need to take away the 1 on the outside, equals 6. Next we're just going to add that 1 to both sides, really simple. So we've got x minus 1 squared equals 7. Extend my lines even more. We're nearly done though. We're going to square root both sides, so it's going to be x minus 1 equals root 7, and then we're just going to add 1 to both sides. So x equals 1 plus or minus root 7. Now the reason that plus minus is there is when you square root a number you get a positive and a negative answer. So our answer is a will be 1 and b will be 7. Again, this question says y is directly proportional to the square of x. So to show proportional, we use this sign here. It looks like a fish. And it says that it's proportional to the square of x. So that's going to be x squared. Now to get rid of that fish, or alpha, whatever you would choose to call it, what we need to do is introduce a constant which we call k on the right hand side. Like so. And actually a lot of students miss out that first step and just go straight to the second. Y equals kx squared. Okay, now that's our general formula, but we need to find out what k is. So we're going to go off to the side to find out what k is. And I'm going to put in the values of 50 for y and 5 for x. So 50 equals k times and then 5 squared. And let's put in my lines. So that's going to be 50 equals 25k. Divide both sides by 25. And 2 equals k, or k equals 2. So we found out what k is. So we're back to our formula. And we know that y equals 2x squared. Okay, the reason we know that is because k is a constant, it won't change. So if it's 2 for that situation, it's going to be 2 across the board. It says find the value of y when x is 4. So we're going to substitute 4 into it. So y equals 2 times 4 squared. 2 times 4 squared, so that's going to be 2 times 16. 2 times 16 is 32, so y is going to be 32. Now, this is a question about composite functions, and I'm going to start this question off by just answering this question. What is f bracket 4? Now, this equation here, up until this level, that used to be y equals 4x, and the question we have here would be what is y when x equals 4? It's the same question, it's just a different way of writing it. So all you need to do for f brackets 4 is feed in 4 as x. So that's going to be 4 times 4, which is 16. Okay, same answer as this, and it's the same question just written differently. And at this level you need to be comfortable with function notation rather than y equals. Okay, now I said I'd ignore the g. The g says, oh okay, when you're done with f, g wants to do it as well. So what I should be writing is this, and I still have to apply a g to all of this. Let's get rid of that. And so I still need to apply the g to the 16. So we've done the f, and the f we did first because it's closest to the brackets. So whichever one's close to the brackets you do first. Okay, we've done the f. Now we need to do the g, and we just do exactly the same thing. So g of 16. We're going to feed 16 into the equation. Well, it says 7 plus 2x, so it's going to be 7 plus 2 times 16. Well, I know 2 times 16 is 32, and I know 32 plus 7 is going to be 39. 39, okay. And so therefore the answer is just 39. Okay. Perfect, right. The next one. This time it's important to notice that the f and g are the other way around. So it's g that we're going to be doing first and then f. Now the thing we're feeding in is x. Well, you can't feed in x as x. Well, you can. It's just going to remain as x. So let's focus on the g first. So we're going to do g of x first. Now g of x is just given to us in the question. It's this bit here. So it's going to be 7 plus 2x. Now f wants to then use that 7 plus 2x and feed it into the f of x equation. So f of x is 4 times x. We're feeding in the 7 plus 2x, so it's going to be 4 times 7 plus 2x. Then we can expand that a little bit. So 4 times 7 is 28, plus 4 times 2 is 8x. Okay, now there's an equation here which I've kind of ignored up until now, but we need to write it now. So it says that 28 plus 8x, which is the fg brackets x, equals 52. So let's sort that out, solve that. So the first thing I can do is take away 28 both sides. And if it's on the calculator paper, you might as well use a calculator to double check your answer. If it's not on the calculator paper, I think most of you will be able to work that out. It's 24. And then we want to divide the 8. So we get x equals, so it's x equals 3. Okay, so the first thing to do in this question is notice that we've got a bracket squared and another bracket squared. So the first thing to do is you need to write those brackets twice. If you don't do that, you end up squaring the 3 and squaring the root 2 and then thinking that you're going to get the right answer. Unfortunately, you can't get the right answer with just squaring the two of them because they are quadratics. So I'm going to write them out as two brackets because anything squared is itself times itself. Okay, now we're going to expand these. Now I'm not going to go into the methods of expanding quadratics, but we've got loads of videos on our channel and our website to help you with that. So use whatever method you are comfortable with, whether it's FOIL or smiley face or whatever you want. I'm going to put them into brackets though. So 3 times 3 is 9. Then we've got plus 3 root 2 plus 3 root 2, so plus 6 root 2. And then we've got root 2 times root 2, which is plus 2. Okay, so second one, 3 times 3 is 9. And we've got minus 3 root 2 minus 3 root 2, which is minus 6 root 2. And then we've got minus root 2 times minus root 2. 2 minuses make a plus, and root 2 times root 2 is root 2. Now, the reason I kept them in brackets is because this is really important. There's a minus 1 there, and it means we've got to multiply everything in the second bracket by minus 1. So the first bracket's unaffected, so we're just going to get rid of the brackets there. Don't need to worry about that. But the second bracket, I need to times everything by minus 1. So that first one is minus 9. The second one is, well, minus times a minus is a positive 6 root 2. And then a minus times a positive is a minus, so minus 2. That means that we can cancel out the 9s there. We can cancel out the 2s there. And all we're really collecting here are the roots. So 6 root 2 plus 6 root 2 is 12 root 2. Now it says it wants it in the form a root b. So a is the number outside the surd, which is 12, and b is the number inside the surd, which is 2. The place to start with this question is just understanding that there is a triangle, and you might not know that there is a triangle for this because you might be taught it in a slightly different way. But if you were to draw a triangle for us, frequency, density and class width were at the bottom and frequency at the top. Now it's a little bit misleading because actually this is proportional to the frequency density, so it's technically proportional to each other. So if you did frequency divided by class width, you might get half of what the frequency density is. So just be a little bit careful, and if they're looking for that type of question, they will give you a bar on the histogram and a value in the table that show you what you have to times them by to get to the frequency density. However, in this one we're actually asked to draw a histogram ourselves, so we don't need to worry about it. Okay, so the first thing I want to plot is our class widths on each of these because I'll need to know what they are. So the first class width, where it's 0 to 10, so the class width is 10. The next one's 10, and be careful because actually the next one is 20 to 25, so that's only 5, that one. The next one's 10 and the last one's 15. So when I've got the class width, I can work out the frequency density. And the frequency density is the frequency according to the triangle divided by the class width. I want to divide these. Okay, so we've got 9 divided by 10, which will be 0.9. 1 divided by 10, which is 0.1. 6 divided by 5, well that's 1.2. 3 divided by 10, which is 0.3. And 6 divided by 15. Well, if I've got a calculator it's easy, but here I can divide top and bottom by 3, so that's 2 over 5. So that's 2/5, which is 0.4. Okay, now notice that the frequency density is not plotted for us, so we've got to come up with a scale. Our highest one is 1.2, So can I go up in ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2. So that would be perfect. So I can go up in ones on the 5 squares. So it would be 0.2 here, because they're 2 squares, 0.4, 0.6, 0.8, 1.0, or just 1, and then 1.2 at the top. Okay, now next thing I want to draw the bars. So our first bar is 0.9 high, and it's 0 to 10. So we want 0.9 high, which will be here, and 0 to 10. Okay, next one is 10 to 20, and it's 0.1. So it'll be down here. I'm not going to get these exact, but with your one, it's a bit easier to get exact. So 20 to 25, so we've got to be careful with this one, because it's only one square across. Let's try and get it as close as I can. So that's 1.2, but it's only 1 square across. Okay, next one, 25 to 35 is 0.3, so that would be there. And last one is 35 to 50 and 0.4. So we go up one, and then we finish that off. Excellent. Okay, so the next question says work out an estimate for the number of trees greater than 40 meters. So I want to draw a line up from 40, and we want it to go across here. So we're looking for an estimate for the amount that are in here. Well, if you look at it, I've shaded in 2/3 of that last group. In the last group there are 6. So I want to find 2/3 of 6, because the total frequency for that bar is 6, and we're looking for 2/3 of it. Well, 1/3 of 6 is 2, so 2/3 of 6 is 4. Okay, so in this question we're given 5 times square root 125, and we're asked to make it in the form 5 to the power of something. So this bit here is kind of our objective. We've got to make this so it's just a single power of 5. Well, 5 at the moment, well, that's quite nice of them to give us a 5, but 5 is to the power of 1, and that's going to be maybe important later on. So 5 to the power of 1 is just 5 times. Now, I notice 125 is actually 5 cubed, so I'm going to rewrite that as 5 cubed. 5 times 5 is 25, times 5 is 125, so that might help us. I'm thinking, right, that square root I can rewrite as to the power of a half. So I'm going to get that 5 to the power of 3, and I'm going to put that to the power of a half. To the power of a half and square root are the same thing, and that's something you need to know about indices. Okay, now the second rule that I'll need is if I've got a number inside and a number outside of a bracket, which I do here, I times them. So that's going to be the same as 5 to the power of 1.5, or 3 over 2. Okay, or 1.5. I could just write it as 1.5. It doesn't matter. Okay, it's sometimes easier to do just a top-heavy fraction, because obviously when you're writing powers, you're already writing small, and it gets a bit complicated otherwise. So it doesn't matter. And the other rule I'll need to know about indices is when you times them, you add the powers. So it's going to be 5 to the power of 2.5. And it says write your answer as a decimal. So it's 2.5 as a decimal, it's just 2.5.
Okay, so this doesn't seem like the easiest questions, because there's 3 shapes going on. There's no numbers in it at all, and we're asked to find a formula. So the first place I'd start is working out, well, first of all, what are the formulas we'll need? Well, let's have a look. So we've got a hemisphere. And some of these formulas you will be given. So a hemisphere is a volume of a sphere and then halved. So instead of 4 over 3, I can just say 2 over 3, which is half of 4 over 3, pi r cubed. The cone that we've got is going to be 1/3 pi r squared h. And then the cylinder we have is the area of the circle times the height. Okay, now we need to find out what the bits are. So for the hemisphere we just need r. Well, that's quite simple because r is just going to be x. It's the radius of the hemisphere. Okay, now what's more difficult is to work out the height of the cone. Well, if the radius across to the right is x, the radius of the circle up is also going to be x. So we know the height of the cone is going to be 4x because one of those x's is used on the hemisphere. We know the radius of the cone is going to be x because it's stated at the top. So let's keep going. The radius of the cylinder is going to be 10x. And the height is just labelled as h. So that's nice and simple. Okay, now let's have a look at what this question's saying. It's saying that this thing here is going to be melted down and is going to be used to create this. So that's just saying that the volumes are going to be the same. So if I add the volume of the hemisphere to the volume of the cone, it should equal the volume of the cylinder. Okay, so we know that a hemisphere plus the cone volume, and I should write volume here, show the examiner that I'm working with volumes, equals the volume of, I don't know why I wrote an S, my goodness, C for cylinder, wow, tell my maths teacher, right, cylinder, there we go. So hemisphere is 2/3 pi, and we said that x was the radius, so x cubed, brilliant. So plus the cone. Now what did we say the height of the cone was? We said the height of the cone was 4x, so it's going to be 1/3 pi x squared because the radius is x, and is it 4x? Let's double check that. Always double check. Yeah, it is. Okay, so the cylinder, and I'm going to leave that up so I can see it, is pi, and what's the r? So pi times 10x squared, and all of that squared because all of that is r, times the height, so times h. Okay, so this is the formula we've got to work with. I'll put my lines down. Okay, so what we got? Let's sort out the timeses first, and let's tidy this up. So that hasn't got any timeses in it. This we're timesing it by 4, so it's going to be 4/3 pi, and I'm timesing it by x, so that's going to be x cubed. This one, I'm doing the 10x squared, so I need to square the 10 and the x, so it's going to be 100. And let's do the pi next, pi, and it's going to be x squared h. Okay, now if you notice on the left hand side, these two here are the same. There's both pi x cubed, so we can just add them together. So it's going to be 2/3 plus 4/3, so that's going to be 6/3, or just 2. So it's going to be 2 pi x cubed equals 100 pi x squared h. Brilliant. Okay, now let's just check to see what it wants. It wants a formula of h in terms of x, so it wants h equals. Okay, so first thing I need to do, well, let's have a look. What's easy to do? Well, what's easy to do is just divide both sides by pi. Let's get rid of the pi's. So 2x cubed equals 100 x squared h. Now we want h on its own, so we're getting close. We need to divide by the x squared first to get h on its own. So I'm going to divide by x squared, so we get 2x equals 100h. So we can already see we're really close. So to get h on its own, we need to divide both sides by 100. And that's going to be 2x over 100 equals h, or h equals, and we can cancel the 2 and the 100, we can divide them both by 2, equals x over 50. So our answer is h equals x over 50. To simplify a fraction, you need to divide top and bottom by something. So if I just try and divide top and bottom by something now, I need to find something that all 6 terms have in common. Well, there is nothing that all those terms have in common. So the way of starting this is to factorize the top and bottom, so put them into brackets, and then something will turn up. So let's factorize the top. So I know it's going to be x at the start. I need 2 numbers that add together to make 12 times together to make 35. Well, that's going to be 7 and 5. Then I need to factorize the bottom. Now, a little bit of a cheat here. I know one of them will be the same. So either one of them is going to be x plus 7 or one of them is going to be x plus 5. So I need 2 numbers to add together to make the 10x times together to make 21. Well, I know that 5 doesn't go into 21, but I know 7 does. So x plus 7 and x plus, well, to make the 21 and the 10 needs to be 3. And all you need to do is divide top and bottom by, let's do it top and bottom. Get rid of that. Ugh. So all I need to do is divide top and bottom by x plus 5, x plus 7 even. And what that does is just gets rid of that and gets rid of that. The fraction stayed the same, but now it's x plus 5 over x plus 3.
Okay, in this question we're asked to convert that fraction with surds in it into this. Now something I notice about what it wants me to convert it into is there's no fraction there. So that hints to me that I might need to rationalise the denominator. So I'm going to start by rationalising the denominator and basically seeing what happens. So to rationalise the denominator, all you do is you times top and bottom by the surd at the bottom. So we're going to times the top by root 2. And to do that, because there's multiple terms on the top, I put them in brackets, and times root 2 by root 2, which is just going to be 2. Then I expand the brackets, so that's going to be square root 64, because with surds, if you times surds, you can just times the numbers and keep it in a square root, plus 50 root 2, and obviously that's still over 2. I know root 64 is just 8, so it's 8 plus 50 root 2 over 2. And then what I can do is just divide top and bottom by 2. Now be careful here, if there's multiple terms at the top, which there are, you've got to divide everything by 2. So that's going to be 1, that's going to be 4, and then 50 root 2 is just going to be 25 root 2. So that is 4 plus 25 root 2. So the A, the bit at the start, is going to be 4, and the B is going to be 25. Okay, the first question asks us to find where the y-intercept. Now at the y-intercept x is 0, so if you have a look at our equation, these two will be wiped out because anything times 0 is 0, and we're just left with y equals minus 4. So x is going to be 0, and y is going to be minus 4, so that's nice and easy. And basically, whenever you just have a number in an equation, the y-intercept is that number, so it's going to be minus 4. The next question is pretty complicated, so we're going to break this down. It does ask us to complete the square. It gives us a bit of a hint. So I'm going to start with completing the square. So we've got x squared minus 8x minus 4. And to complete the square, what we do is we put brackets and we do x, and we do half of the coefficient of b. So half of this, and b is always the number before the x. So half of minus 8 is going to be minus 4. And we close bracket and put a squared there. Now if I expand that up here, x times x is x squared. Then you have minus 4x, and plus 16. So we get x squared minus 8x plus 16. Now, we want the x squared minus 8x because that's what the equation in the question is, but we don't want this bit, that plus 16. So we're going to subtract, get rid of the 16 by taking away 16 there. And we've also got the minus 4, which is in the question to have as well. And we do have videos on completing the square, which go into it a little bit more detail than I'm going through here, so watch those if you're not sure. Go put the minus 16 and the take away 4 together. Okay, so here we've got an x and we're subtracting 4, we're going to square that and then take away 20. Now, the next thing to think about is comparing it to y equals x squared. Okay, y equals x squared looks something like this, and I'm going to do a really bad job of doing this, but something like this, okay? And that's y equals x squared. So if you think about that function, and we're going to call that f of x, then what's happened between that and the one that we've just created? Well, in terms of f of x, this one is going to be f, which is the function is squaring, of x minus 4, okay, and we're going to square it, take away 20. So think about functions. What do the bits do? Well, anything in here moves it in the opposite direction on the x-axis. So minus 4 would move it 4 to the right, and anything in here will shift it on the y-axis, and actually it will be in the correct direction. So anything inside the bracket affects the x in kind of the opposite direction, and anything outside the function will just affect the y. So the minimum point on y equals x squared is 0, 0. And we're moving to the right 4, and then we're moving down 20. So it'd be minus 20. So the new point will be at 4 minus 20, and that's going to be the point at t. A little bit complicated, but once you get really good at completing the square and really good at understanding transformation of functions, then this question just brings the two together and you shouldn't have a problem. If you had any issue with this, obviously have a look at completing the square and have a look at transforming graphs and transformation of functions, and that will help you massively with this. I hope you enjoyed that video. If you like what you see, please click subscribe and then you'll get notified on all the content we put out. Also, check out our YouTube channel. We've got all the topics in the Maths GCSE collated by grades, by topic, by tier. We're finding that it's really, really useful resource. I think we've got hundreds and hundreds of videos. They're tiny little videos on each tiny little topic, which students are finding useful. Don't forget to check out the website as well. Everything on the website, all the online papers, everything we put out on the website is completely free. And also don't forget, if you really like what you see and you want to support the site, please click this link now above me, and that will take you to the supporters club. Thank you very much.